An object is being thrown at a speed of 20 meters per second in a direction 45 degree above the An object is being thrown at a speed of 20 meters per second in a direction 45 degree above the horizontal. The time taken by the object to return to the same level is. See, we know that time of flight at 45 degree is equal to root 2 u by g, which means it will be root 2 by g into how much is the velocity? It is 20 meters per second. So 20 root 2 by g. D is the correct option. Now, if we try to solve this question otherwise and understand the importance of what's given to us. So basically, we've been asked to find out the direct application of this formula. T is equal to 2u sine theta upon g. But before we go any further, for those students who want to understand the concept well, let us discuss the idea in detail. So this is an object being projected at velocity u at an angle theta, right? From A, it reaches B, the maximum height. So P is the maximum height, and it comes to C, back to the flow. Now, we know that when a body is projected with velocity u, it will at an angle theta, it will have two components. One will be ux and the other will be uy. I repeat, when an object is projected with velocity u at an angle theta with the horizontal, it will have two components of velocity, one being the horizontal component and the other being the vertical component, uy and ux. And from this triangle, what is ux is equal to? Ux is equal to u cos theta, and what is uy is equal to? Uy is equal to u sine theta. Now, what we need to understand is, we're going to apply the equation, third equation of motion here, which is s is equal to ut plus half at square. Now, what we need to understand is that when we use s is equal to ut plus half at square, this s can be divided into two different components. One is along the x component and the other is along the y component. So s component s would be written as sx and y component y would be written as sy. Now, what do we mean by this? It means that at C, sx is equal to ac and sy is equal to 0. That is, displacement has two components, vertical component sy and horizontal component sx. As velocity has two components, ux and uy, displacement will also have two components, sy and sx. So what does sy represent? Sy represents the displacement in the vertical direction and sx represents the displacement in the horizontal direction. So when we say sx at C, this was the initial position, this is the final position, which means AC is now the horizontal displacement. So displacement in the x direction, sx is AC. Now what is y? Sy is the displacement in the vertical direction. When the object is at C, is there any vertical displacement? No. So if you draw a vertical axis here, at this point, it has both vertical displacement as well as horizontal displacement. At this point, it has both vertical displacement as well as horizontal displacement. But it comes here, the vertical displacement decreases, the horizontal displacement increases. At this point, the vertical displacement becomes 0 and the horizontal displacement becomes the maximum, which what we call as range, right? But what we need to understand is, while applying this equation, if we write it as sy, you need to convert every term into y component. So sy is equal to uy into t plus half into ay into t square. Now, what is the vertical component of displacement when at C? At C, the vertical component of is 0. So this becomes 0 is equal to, what is uy? Uy is u sine theta. And what is t? If here we denote as capital T, which is time of flight, plus half into what is AY. We know that AY is minus G into T square. So what do we get? The expression for T is equal to 2U sine theta upon 2U sine theta upon G. Okay, so that's about the time of flight. Now let us also discuss another point, which is, okay, let me write down the formula again. So we have time of flight, right? So we have time of flight T is equal to 2U sine theta by G. Now what we need to understand a bit further here is, for the same velocity, for the same velocities, two bodies being projected at two different angles, theta 1 and theta 2, means if we have an object projected at U at angle theta 1, another object projected at same velocity but a different angle theta 2, if this is time of flight T1 and this is time of flight T2, then what we can say is T1 by T2 would be equal to 2U sine theta 1 by 2U sine theta 2, or in short, T1 by T2 will be equal to sine theta 1 by sine theta 2. Okay, so this is another thing that what we can keep in mind. Is there anything else that we could say? Yes. Additionally, what we can write is, we know time of flight T is equal to 2U sine theta by G. Now when is this applicable? When an object is projected with an velocity U with respect to the horizontal theta, right? In which case T is Tu sine theta by G. Now what will happen if the object is projected with velocity U but not with respect to the horizontal? If it is projected with respect to the vertical as theta, and yet if the body goes through a projectile motion with time of flight T, what will time of flight be equal to? Will be equal to 2 into sine of by G, sine of the angle made by the horizontal, right? So what is the angle made by the horizontal? See, if this much angle is theta, what is the leftover angle? That would be 90 minus theta, right? So this much angle is 90 minus theta. So this here T will be equal to 2U sine 90 minus theta. Let us take T1 and T2 for our reference. So we have T1 and T2. Okay. Now let us find the ratio between T1 and T2. So what is T1 by T2? T1 by T2 will be equal to 2U sine theta by G times G by 2U sine 90 minus theta, right? Which is further equal to T1 by T2 is equal to G and G by is 1, 2U by 2 is 1, sine theta by, what is sine 90 minus theta? Sine 90 minus theta is cos theta. So what we get is T1 by T2 is equal to sine theta by cos theta. Therefore T1 by T2 is equal to tan theta. Is a very important result that may be required while solving problems at the next level. Okay, is there anything that we could add? We discussed about theta, we discussed about, okay, let us now discuss one more thing regarding the formula. So what is T is equal to? T is equal to 2u sine theta by g. Now for a constant angle of projection, theta, T is equal to 2u sine theta by g. What I mean is when I say constant angle of projection beta, what with u varies, which means I'll fire the object with u at an angle theta. In the second case, I'll fire the object with 2u at an angle theta. In the third case, I'll fire the object with 3u at an angle theta. So what remains constant? Angle of projection theta constants. But what varies? U varies. U, 2u, 3u. In which case T is proportional to 2 by g into sine theta into u, not proportional to. So T is equal to 2 by g into sine theta into g, 2 by g into sine theta. Now, g is a constant, 2 is a constant. If theta is a constant, sine theta will also be a constant. So, which means we have T is equal to constant into a constant is a constant. That constant divided by constant will be another constant. So, we have T is equal to k into u, or in other words, T is proportional to u. When T is proportional to u, let us say if this was T, and if in this case, if the time of flight is T dash, right? What will, so we can write here that T is proportional to u, and what is T dash? T dash will be proportional to 2u. In which case, if you take T by T dash, what do you get? U by 2u, or in other words, you get, oh, it's not T1, it's T dash, right? Okay, either way, so T dash is 2t, or generally we can write that in general T dash will be equal to n times t. So I think these are the minimum variations that you should be knowing. Okay. Oh, was one another important thing, which is with respect to the angle. So T is equal to, again, what is T is equal to? 2u sine theta by g. So we'll discuss three cases when theta is equal to. So let us say when theta is equal to 30 degree, theta is equal to 45 degree, and theta is equal to 90 degree. So when theta is equal to 30 degree, what is T is equal to? 2u into sine 30 by g. T is equal to 2u into sine 45 by g. T is equal to 2u into sine 90 by g. So we have T is equal to, what is sine 30? 1 by 2. So this will become 2u into 1 by 2 the whole upon g, which is equal to u upon g, right? Because 2 by 2 is 1. And here what we get is 2u into 1 by root 2 the whole upon g. So this is root 2 u by g. And for 90, what we get is, what is sine 90? Sine 90 is 1. So what we get is 2u by g. So we got u by g, root 2 u by g, and 2u by g. And for ease of calculation, we may, if g is assumed to be 10 meter per second square, then we can assume that t is equal to u by 10 at t is equal to 30 degree, and at t at 90 degree it is u by 5. Why u by 5? Because 2u by 10, right? So that becomes u by 5. So these two formulas can also help you in saving your time while doing problems with more number of steps. What is that? Time of flight at 30 degrees, velocity divided by 10. Time of flight at 45, 90 degree is initial velocity divided by 5. Okay, so that's it with this question based on time of flight. Let us do the next question from NEET previous year.